Welcome to The Explainer. Today we're exploring one of the most explosive, dramatic, and, well, absolutely vital epochs in the entire history of the cosmos. We're talking about the very first stars to ever ignite. And listen, these weren't just ordinary stars like our sun. No, they were towering behemoths that lived incredibly brief, violent lives. But here's the crazy part. Without their ultimate explosive sacrifice, literally nothing in our modern universe, including you and me, would even exist.
So, to really understand why, we gotta rewind the clock. Imagine a universe completely devoid of starlight. After the Big Bang, as that initial flash of creation faded out, the universe expanded and cooled into this long, dark silence. For 380,000 years, it was trapped in what astrophysicists actually call the Dark Ages. There were no galaxies, no planets, and absolutely no stars. Just a vast, expanding sea of dark gas. Okay, let's dive into this timeline. The cosmos didn't stay dark forever, right? It eventually transitioned from this pristine, dark slate into the actual dawn of starlight. It took hundreds of millions of years, but eventually gravity started pulling that dark, quiet gas together to form the very first points of light, bringing an end to those cosmic dark ages. But there was a major catch. This early universe was literally a blank slate, chemically speaking. The Big Bang really only had the time and the energy to forge the absolute lightest, simplest elements, basically just hydrogen and a little bit of helium. And that's it. So that means the very first stars, which scientists call population 3 stars, they had to be built exclusively from this incredibly basic elemental toolkit.
Now, interestingly enough, astrophysicists have a slightly lazy but honestly pretty brilliant way of looking at chemistry. To an astronomer, hydrogen and helium are pretty much the only normal elements. Everything else, carbon, oxygen, gold, iron, they just lazily lump it all into one giant category, metals. They basically just stamp metals right over the rest of the periodic table. And since the early universe had absolutely no metals, these first stars had to figure out how to form without any of the heavier stuff we take for granted today.
Section 1. The gravity and pressure struggle. So to understand how any star survives, especially without metals, we have to look at its core physics engine. Every single star in existence is locked in this epic, lifelong tug of war. On one side, you have gravity. A star has massive weight, and gravity is constantly trying to crush all that mass inward into a tiny point. But on the other side, you have the intense heat and the outward push generated by nuclear fusion burning away right in the star's core. As long as the outward push of fusion perfectly matches the inward crush of gravity, the star stays alive. Section 2. The cosmic gas cooling problem. So the crucial point is, how do you actually get a giant cloud of gas to collapse into a star in the first place? Well, it needs to cool down. If the gas is too hot, the atoms bounce around with way too much energy, and they just resist collapsing. You see, modern gas clouds are polluted with those metals we talked about, like carbon and oxygen, and these act as fantastic cosmic radiators. They can cool a gas cloud down to just a few tens of degrees above absolute zero, which lets relatively small stars like our own sun gently collapse and ignite. But the early gas clouds, they only had weak molecular hydrogen to cool them. So they were stubbornly hot, stuck at a few hundred Kelvin. Because that early gas was so intensely hot and resistant to collapsing, it required an absolutely massive amount of gravity just to force the gas together. In physics, we call this the Jeans mass. Basically, for these very first stars to even ignite, the gas cloud had to be unbelievably heavy. We're talking often over 100 times the mass of our modern sun. No small stars allowed. Section 3. Giants with very short lives.
These extreme, metal-free conditions gave birth to absolute behemoths with incredibly terrifying gravity. And this brilliantly illustrates the core problem. To prevent themselves from instantly collapsing under their own immense weight, these giant stars had to run their nuclear fusion engines at maximum overdrive. They literally had to smash hydrogen atoms together at an unbelievable rate just to generate enough outward pressure to stay alive. But here's the thing, hydrogen eventually runs out. And when it does, the star has to start fusing helium, then carbon, then oxygen. The star actually develops layers, kind of like an elemental onion, rapidly burning through increasingly heavier and heavier fuels. And the catch is, every time it switches to a heavier element, that fusion process gets less efficient, meaning the star has to burn it even faster just to hold up its own crushing weight. The speed of all this is just staggering. I mean, to put it into perspective, our sun will live for about 10 billion years.
But a primordial giant of, say, 300 solar masses, it burns through its fuel in a total cosmic blink of an eye. In its final stages, it might burn carbon for just 300 years. It'll burn oxygen for a mere 200 days. And that final layer of silicon, it fuses into iron in just 2 days. 2 days.
Section 4. The Great Cosmic Oxidation Event.
This brings us to the dramatic climax of the star's life. Iron is the ultimate cosmic trap. For every single element up to this point, fusion released energy, providing that absolutely crucial outward push. But fusing iron actually costs energy. It absorbs it. So the instant that core turns to iron, the nuclear engine stalls. The outward pressure just vanishes completely. That multi-million-year tug of war, it's over in a fraction of a second, and gravity instantly and mercilessly crushes the star. The entire weight of this 300 solar mass behemoth crashes down onto the iron core at a significant fraction of the speed of light. It bounces off that dense core, resulting in one of the most violent, catastrophic events in nature, a supernova. The explosion completely tears the giant star apart, ending its short, furious life in an instant.
Let's move to Bernard and see how this builds the universe we know today. This wasn't just a death, it was actually an act of creation. We call it the cosmic oxidation event. That massive explosion took all those newly forged heavy elements, the carbon, the oxygen, silicon, and iron, and violently blasted them out into the pristine gas of the cosmos. That blank slate of pure hydrogen and helium, it was permanently polluted with metals. What you should really take away from this is just how deeply personal this ancient history actually is. The very universe was permanently altered by these first giant stars. Because they seeded the cosmos with heavy metals, future gas clouds could finally cool down efficiently and form smaller, stable stars like our sun. They could form rocky planets. Guys, the calcium in your bones, the oxygen in your lungs, and the iron in your blood were literally forged inside the dying cores of those specific ancient giants. It leaves us with a truly profound realization. These massive population 3 stars were pretty much doomed from the start. They had to be huge to form, and because they were huge, they died almost instantly. But without their brief lives and their violent, explosive sacrifice, the cosmos would still just be endless clouds of dead, dark gas. So, would life as we know it even exist if the very first stars hadn't burned too bright and died too soon? Think about that the next time you look up at the night sky. Thanks for watching this explainer and keep exploring.